Hey everybody, it's Al with BobCAD. So today I wanted to look at doing a chamfer in 3-axis. We have this window cut out here, and what we would like to do is to break this edge while the part's in the machine. So in this example, we're going to use a multi-axis toolpath. The multi-axis toolpath that we're going to use is morph between two curves, but you could use morph between two surfaces as well. We have our drive surface set up as the chamfer itself. We have our first curve as the top profile, and we have our second curve as the lower profile. Now, when you get in here and you define your output, one of the things that happens is, let's set this to 50. This is 3-axis. We'll go ahead and compute that. What you're going to see is there's more than one pass happening. It's stepping down. And really, we just want to machine this in one pass. So how can you go about that? Well, the first thing that I'm going to do is I'm going to change my type to determine number of cuts to 1. Okay, and then I'll recompute this. And then this gives me one cut. But the problem is that it's not past the edge of the chamfer. I want it to go further past the edge of the chamfer so I get that intersection nice and clean. So the way that you can have the toolpath drop down is you go to this utility function for axle shift, and we can give this a value to drop it down and then compute. But now when we've dropped it down, literally all it did was drop it down. So we're actually not cutting the surface correctly. We'll be gouging the part. So if we run this through a simulation, we can see that real quick. So one of the things, because it's kind of a smaller part, is I'm going to turn up my tolerance really high and regenerate my model. And then from here, I'm going to run this all the way through the simulation. And it's going to get all the way done. So now we're looking at this area, and you can see how there's a lip right there. If I go to my deviation report, so let me set this up real quick. And run this through. We're going to see that we'll get a color coding, and we're going to see that we have some toolpath left, or I'm sorry, not some toolpath, we'll have some material left right on the edge of this part here once it gets done calculating. And so that's what we want to avoid. We want to avoid that. So we want to actually have the toolpath cut down deeper, but then we want to have it step out. Just give it just a second to finish calculating here. Okay, good. So we got our calculation done. You can see how we're coming up in yellows, oranges, and reds. So we're definitely gouging the part here. We're cutting down inside of the part. So again, that's because we did our axle shift. If we close this out, we get back into here. What we did is we told it, hey, cut down deeper into the part. But when we told it to cut down deeper in the part, we didn't push it out. So how do you push it out? We go to our gouge check, and we're going to do retract tool, but we're going to do this along the surface normal for the drive surfaces. Okay, so now we can recompute this, and you'll see that the toolpath now gets pushed out. And so basically we've dropped it down deeper so it cuts past the edge, and then we gouge checked it to the surface and are driving it along the normal of the surface. So basically it gives us the cut that we want. Even if we drop this down deeper, really what's going to happen is it's going to push it down deeper, but we'll just be using more of the side of our cutter. So let's run this through a simulation. Again, we'll turn up our tolerance here. We'll cycle it all the way through. And then now you can see that we have a nice chamfer on here, and you can see that it's right with the edge of the model. If I ran through the deviation report again, we would see that the gouging has now gone away. So let's go ahead and do that. Just adjusting the scale here. We'll recalculate this. So as you can see in the simulation, we come up all green, and that's letting us know we're right within tolerance. If you guys have any questions or comments about this video, please reply back to the Facebook, the YouTube, or whatever thread this video may be posted in. Otherwise, we'll see you in the next one.